Assalamu alaikum ma'am. Welcome to our video presentation. First introduce myself. I am Rajiv Hoshan Raz, ID 171299969 and introduce my group member IV Rahman ID 181299047 and Faria Islam Lija ID 181299051. Today our presentation topic is history and development of stereoisomer. Now I talk stereoisomer history. Stereoisomer are the isomers that have the same molecular formula but a different three-dimensional spatial arrangement of atom. That is the particular type of isomer that are different from each other only in the way the atom oriented in a space are called stereoisomer. Charles William Scales made an important contribution to stereochemistry when studying the barrels and corks during grape juice fermentation. He discovered racemic acid in 1890 which had the identical structure, same chemical formula of tartaric acid feature. They have identical IUPAC name. They always have the same functional group. Stereoisomer differ in their properties not only to rotate the plane polarized light but in their activity. Classification of stereoisomer. Stereoisomer divided to geometric isomer, optical isomer. Optical isomer divided to anisomer and diastomer. Geometric isomer, also called cis trans isomer, are a type of isomers resulting from a double bond or ring structure. The double bond or ring in the structure means that not all bonds are free to rotate, giving rise to geometric isomer whose shapes cannot interconvert. Optical isomer are molecules whose structure are a mirror image that cannot be superimposed one on one another in orientation. Such molecules are said to be chiral. For example, D-lactic acid, L-lactic acid. Diastomer are defined as non-mirror image, non-identical stereoisomer. Hence, there occur when two or more stereoisomer of compound have different configuration at one or more of equivalent stereocenter and not mirror image of each other. Anisomer are chiral molecules that are a mirror image of one another. Furthermore, the molecules are non-superimposable one on another. This means that the molecules cannot be placed one top of one another and give the same molecule. Chiral molecule will with one or more stereocenter can be anisomer. Thank you ma'am, and invited my next group member IV Rahman.
Thank you, Rajiv. Assalamu alaikum. Thank you, ma'am, for giving me a golden opportunity to say something about my presentation. Our presentation topic is history and development of stereoisomers. My group member Rajiv Hoshan Raz have already discussed about the introductory part of this topic. Now I want to discuss about the development of stereoisomers and related drugs. Stereoisomers are the molecules that are atomic constitution but differ in three-dimensional arrangement of the atom. For this document, the stereogenic pairs of the greatest interest, one of the more asymmetric centers whose enantiomers are mirror image. It is related to the study and development of pharmaceutical industry, the enantiomers and racemers. It is usually required the specialized techniques for their correct identification, characterization, separation and measurement. The importance of stereoisomers is drug action in greater gaining attention in the medical practice. The importance of stereoisomers, as a result, many of the drugs are currently used in psychiatric practice of the mixture of enantiomer. There are some drugs which are related to the stereoisomers, such as ketoprofen, ibuprofen, salbutamol, naproxen, etc. Now I want to discuss about ketoprofen and salbutamol. Ketoprofen. Ketoprofen is the most propanoic acid and non-steroidal anti-inflammatory drugs. It contains the equal quantities of the R and S isomers. Its effectiveness is dependent on the S isomers, which inhibit the synthesis of prostaglandins. It is used as analgesic and antipyretic. It is also used in pain such as nerve pain. Side effect: nausea, vomiting, abdominal pain, headache, etc. Now, salbutamol. Salbutamol is discovered in 1966 in England, launched by Vandrollin in 1969. It is formulated with racemic mixture of the R and S isomer. The R isomer 150 times greater affinity of the beta receptor than S isomers. The S isomers have been associated with toxicity. Use: it is used to treat wheezing and shortness of breath. It is treated by relaxing muscle of the airway of the lungs. Side effect: headache, muscle cramps, dry mouth, etc. Now I would like to invite my next group member, Faria Islam. That's all about me. Thank you.
Thank you, Ivy. Well, Assalamu alaikum, ma'am. Welcome to my video presentation. I am Faria Islam Lija and my ID 1812905. Today our presentation topic is about of stereoisomer. My group member already discussed about of history and some part of development of drug of stereoisomer. Now I am discuss about the development of drug and application of stereoisomer. Now I am discuss about two drugs of stereoisomer such as ibuprofen and naproxen. Ibuprofen. Discovery of ibuprofen. Ibuprofen was discovered in 1961 by Stuart Adams and initially marketed as brufen. It is available under a number of trade names including Advil and Motrin. Drug class: non-steroidal anti-inflammatory drug. Uses: 1. Ibuprofen is used to relieve pain from various conditions such as headache, dental pain, menstrual cramps, muscle aches, or arthritis. 2. It is also used to reduce fever and to relieve minor aches and pain due to the common cold or flu. Side effect of ibuprofen. Common ibuprofen side effect may include upset stomach, mild heartburn, nausea, vomiting, gas, diarrhea, constipation, dizziness, headache, nervousness, decreased appetite, mild itching, etc. 2. Naproxen. A discovery of naproxen. Naproxen was discovered in 1976 as the prescription drug naproxen, and the first marketed naproxen sodium under the brand name Anaprox in 1980. Drug class: non-steroidal anti-inflammatory drug. Uses: naproxen is used to treat headache, nausea, muscle aches, dental pain, menstrual cramps. 2. It is also used to reduce pain, swelling, and joint stiffness caused by arthritis, bursitis, and gut attacks. Side effect: the common side effect that occur with naproxen oral tablet including stomach pain, constipation, diarrhea, heartburn, nausea, vomiting, and dizziness. The serious side effects include chest pain, shortness of breathing, difficulty speaking, high blood pressure. Application of stereoisomer. 1. Stereoisomers are important in metabolism too. D-glucose is readily utilized in human metabolism. 3. In many cases, only one of several isomeric forms of a compound can take part in biochemical reaction. Thank you, ma'am.